Okay, this is the review for the area quiz, area and polygons quiz. So number one, we want to find the area of each shape. So we're gonna step on it. Right, so we have the area of three different figures. We have the area of circles, which is pi r squared. So the area of a circle is pi r squared. The area of a rectangle is length times width. And the area for a triangle is 1/2 the base times the height. So we're going to use these three areas to find the areas of these more complicated figures. And we're going to do it by breaking down these figures into circles, rectangles, or triangles. Okay, so our step one is to identify the components. Then we want to find the area of each component. And then we want to use addition or subtraction to find the total area. So for number one, there's two different ways we can do it. We can either cut off here and make two rectangles, or we can cut here and make two rectangles. If we look at our first rectangle, if we redraw it, we notice it is 7 by 3. So the area of a rectangle is length times width. The area of this is going to be 3 times 7, which is 21. To find our other rectangle, we know it has a width of 2. We need to find the length. We know the length of this whole piece is 15. We also know, since this is a 7, the opposite side of the rectangle is also going to be 7. So this piece has to be 15 minus 7, which is 8, right? That's our simple segment addition postulate. These two have to add up to 15. So 15 minus 7 gets us 8. So our length is 8. Again, area for a rectangle is length times width. So we have 8 by 2, which is 16. So the question is to find the area of the shape. So we have to add together the area of both rectangles to get the area of the whole thing. So we're going to do 21 plus 16, which is 37. At number 2, we're also going to break down into two different rectangles. So our first rectangle, it has a width of 6. So if we redraw it, well, we'll draw it after. Let's figure out all the pieces first. So this piece right here is 3, and this piece is 4. So if we put these two together, the total width of the whole figure is going to be 7, which means this piece up here is 7. Okay. So this big rectangle is 7 by 6. Okay, the small rectangle, okay, we know is 4, but we have to find the length of that one. We know the whole length here is 9. We know opposite sides of a rectangle are the same, so this piece is going to be 6. So we know this is right here. From here to here is 6. Since the whole thing is 9, this piece to this piece is going to have to be 3. Okay, because those two need to add up to 9, 3 and 6. So we know it's 3 by 4 and 6 by 7. So the area of a rectangle is length times width. So we have 7 times 6, which is 42. Here we have length times width. So we have 3 by 4, which is equal to 12. So if the area here is 12, the area here is 42. We have to add them together, and our total area is going to equal 54. 42 and 12 is 54. Number 3. We can break now. The step 1 in our process, right, is to break them down, identify the components, triangles, rectangles, or circles. Step 2, we want to find the area of each part, and then step 3, we want to add or subtract as appropriate. I guess we got to zoom out a little bit so we get the whole thing in here. Or we can put an exact percentage, right? So how about 280? So for number 3, we can divide it into a rectangle and a triangle. Again, we didn't want to make it too complicated, so we erased that and made this side 5. So this is the problem we want to work with. Okay, we're just putting 5 there again to make the problem easier, because in reality you have to then do Pythagorean theorem. So it's just easier if we have the problem say 5 instead of 7 for our purposes. Okay, so a rectangle is 17 by 10. So the area is the length times the width. So our area is 17 by 10, which is 170. Okay. The triangle, we have the height. Now we need the base. Okay. So our area for a triangle is 1/2 BH. The base is, we don't know yet. Height is 5. So the question is, how do we find the base? Well, we know the rectangle is 17 inches across. So on the other side, it's also going to be 17 inches across. So this distance is 17. So if this is 13, this piece has to be 4 because we have to add up to 17. 4 and 13 is 17. So our base is 4. So our area is going to be 1/2 times 4 is 2. 2 times 5 is 10. So the area of the triangle is 10. The area of the rectangle is 170. So the total area is going to be 170 plus 10, which is 108. Number 4. We can break into 2 rectangles and a triangle. The dimensions of this rectangle are 18 by 26, right? 39 is the whole length. So we want the dimensions of this big rectangle. It's going to be 18 by 26. So the area is length times width. So area is going to be 18 times 26. Okay. Which is going to give us 468. Since this whole thing is 39 meters long, and this piece we know is 26, right? We know that this piece right here, this piece I'm highlighting right here, is going to be 26. So what's left? 26 and 13 is what we need to get 39. So 39 minus 26 is going to give us 13. So this rectangle is going to be 4 by 13. So area is length times width. So it's going to be 13 times 4, which is going to be 52. 3 times 2, 13 times 2 is 26. 26 times 2 is 52. Okay. And then we have a triangle. We need to find the base And the height, so if this is 13, we know the base is also going to be 13. This is 4. We know this piece right here is going to be 4 as well, because opposite sides of rectangles are the same. If the whole thing is 18, this whole thing is 18. Right? From here to here is 18. 18 minus 4 is going to give us this piece, which is then going to be 14. So 18 minus 4 is 14. So these two have to add up to 18. So the base is 13, the height is 14. So the area of a triangle is 1/2 the base times the height. So we have 1/2 13 times 14. Okay, 1/2 of 14 is 7. 7 times 13. So that's 26, 52, 73, 86, I believe. Could be wrong, but I think it's 86. Guess it's 91. 78 plus 13 is 91. I'm really tired. 91. Or just not as good at math as I think I am. Okay, so the area of the big one was 468. The small rectangle was 52. And the area of the triangle was 91. So we add those all together. 468. So 468 plus 91 plus 52 is going to be 611. 468 plus 91 plus 52 is going to be 16 plus 5. 611. Number 5. Okay, number 5, we have a rectangle and half of a circle. So the area for the rectangle is length times width. Our length and width are 6 times 8, 6 and 8. So 6 times 8 is 48. So the area of our rectangle is 48. The area for a circle is pi r squared. So we know the opposite sides. Well, the key is we have to find what the radius is. So we know the length of this side of the rectangle is 6 inches. So we know the length of the opposite side of the rectangle is also going to be 6 inches. Okay. It happens that if we look at the circle, okay, it's not a very good circle, but if we look at the circle, we notice the diameter is 6. Okay, the diameter is going to be 6. Okay, we know the radius is half of the diameter. So the radius is going to be 3. The radius is half of the diameter. So the radius is 3. So here we have area equals pi times 3 squared. This is going to end up being 9 pi, which is approximately, 9 times pi is going to give us 28.3. Okay. But it's not a full circle. It's only half of a circle. So we have to divide that answer by 2. And we end up getting 14 approximately. Area of the half the circle is approximately 14.1. It's not a final answer, right? That's just for the half circle. So the other way you can do it, though, is we can say area is 1/2 pi r squared, because we know it's a semicircle. So you can put the half in at the beginning, or you can divide at the end. Okay, same result. If you put this into the calculator, you would end up getting approximately 14.1. So 48, 14.1. So our total is going to be 62.1. Number 6, we can break into a rectangle and a triangle. The dimensions of the rectangle are 10 by 10. So we have area equals length times width, which is going to be 10 times 10, which is 100. We know that this distance right here is 10. So we know this distance here is 10. So if this piece is 6, we have to do 10 minus 6 to give us 4. So the base of the triangle is 4. We know this distance here is 10, so we know this distance from here to here is also 10. If this whole piece is 16, we can do 16 minus 10 to give us 6. So we know the top piece here is going to be 6. If the whole thing is 16, we can subtract the side of the rectangle, which is 10, to get the height of our triangle, which is 6. So the area of a triangle is 1/2 the base times the height. So 1/2, 4 times 6, which ends up being half times 4 is 2. 2 times 6 is 12. And then we had 100. So our total area is going to equal 100 plus 12. 112. Number 7. Here's another one where we can split it into 2 rectangles. This rectangle is a square, so it's 13 by 13. So the area of the big one is length times width. So area is going to equal 13 by 13, which is 169. We know that this distance right here is 13. Right? 13. So we can do 13 minus 5 to give us 8. And these two pieces have to add up to 13. We can find the area of the smaller rectangle. Area is length times width. So we have a length of 8 and a width of 7, which is 56. So the total area is going to be 169 plus 56. Which is going to give us 225. Number 8, they're asking to find the shaded area. So I'm going to add on to it. Find the shaded area and unshaded area. Where did that comma? I mean the period. Okay. So we have 2 rectangles here. We have a big rectangle on the outside and a small rectangle on the inside. So the large rectangle is 19 by 7. So the area is length times width. 19 times 7. So 20 times 7 is 140. 1 times 7 is 7. 140 minus 7 is going to give us 133. The interior triangle is 4 by 15. So we have 4 times 15, which is going to give us 60. Okay, so the question wants us to find shaded and unshaded. So first, let's start by finding the unshaded area, and then we can find the shaded area. So the unshaded area is the small rectangle, the 4 by 5 rectangle. It's this piece right here. So we know the area of this rectangle is 60. So our unshaded area is 60 inches squared. We know the large rectangle is 133. So this area right here is 133. Okay. We want to subtract the area of the unshaded, the unshaded area. So we want to subtract all of this. Okay. And the area we just subtracted is 60. So we now have 133. Right, so we started with 133. And we're going to subtract 60. Okay, and we are left with 73. Okay, so our shaded is going to be 73. So we took the total of the rectangle on the outside, which is 133, and we subtracted the unshaded to give our shaded answer. So 73 inches squared is the area of the shaded section of that figure. Okay. So now we have number 9. Find the area again of shaded. The shaded area. Okay. So the large rectangle is length times width. So we have 14 by 14, which is going to give us 196. The circle, the area of a circle is pi r squared. Okay, the radius of our circle is 2. So our area is 4 pi, which turns out to be approximately 12 point something. 12 pi. 4 pi, right? $12.6. $12.6. Okay. So we have the rectangle, and then we have 4 of these. So this is 12.6, this is 12.6, 12.6, and 12.6. We want to find the shaded and unshaded areas. To find the unshaded area, we would have to take these 12.6s and add them together. So how many circles do we have? The area of one circle is 12.6. We have 4 circles, so we can do 12.6 times 4, which gives us approximately 50.3. Okay, so it's about 50.3 is our unshaded area. Right, the unshaded area is composed of 4 circles. Each circle has an area of about 12.6. So when you multiply that by 4 for each circle, we're going to get an unshaded area of about 50.3. The rectangle has an area of 196, so all of this has an area of stay in the lines, has an area of 196. Okay, if we subtract 50.3, so subtract our circles here, we're going to be left with 145.7. So our shaded area is 145.7. Area of the rectangle is 196. Area of the circle is 12.6. There's 4 circles, so 12.6 times 4 gives us about 50.3. That represents our unshaded area, the 4 circles. To find the shaded area, we take the total of the rectangle and subtract the unshaded, and that gives us the shaded, which is 145.7. Number 10, the rectangle is length times width. Length is 18, width is 8. 18 times 8 is going to give us 144. We have a triangle with a base of 4 and a height of 4 as well. So the area for a triangle is 1/2 base times height. So we have 1/2 4 times 4. 1/2 times 4 is 2. 2 times 4 is 8. So the area of the triangle is 8. So the area of the other triangles is also going to be 8 because they're also 4x4s. So if we're looking for the shaded and unshaded areas, to find the unshaded area, we take the 4 triangles and multiply, or the area of each triangle is 8. So we have 4 triangles, each with an area of 8. So 4 times 8 is 32. So our unshaded area is 32 inches squared. Okay. To find the shaded, we have to take the rectangle, okay, which is 144. The whole thing is 144. We have to subtract the 4 triangles, which we said was added together was an area of 32. So we subtract 32, and we get 112. So the shaded area is 112. So the area of all of this is 144. And then we subtract there's minus 8, minus 8, minus 8, minus 8, which leaves us with 112. Um, 11 and 12. So find the area of the shaded region. So again, shaded and unshaded is what we're going to look for. The rectangle is 25 by 15. So area of the rectangle is length times width, which is 25 times 15, which is going to give us, I believe, 375. 25 times 4 is 100. So that's 100, 100, 100, and 100 minus 25 is 370. Okay. We have a triangle. 1/2 base times height is the formula. The base we have is 5. The height we have is 3. Okay. So 15 over 2. Okay. We want to find the shaded and unshaded areas. Okay. So the area of one triangle is 15 over 2. So we have another triangle. So we have 15 over 2. We multiply by 2 because there's 2 triangles. 15 over 2 times 2 is going to equal 15. Okay, so the unshaded area is going to be 15. The unshaded area is composed of 2 triangles. Each triangle has an area of 15 over 2. So the dashes tell us this is 3 and this is 5. So we know it's the same area for the triangles. Okay. So the unshaded area is 15. We know the shaded area, or the whole area, is 375. If we subtract the shaded area, so if you subtract 15, so here's minus 5 over 2, minus 7.5, minus 7.5, which is 15 over 2, we end up with 360. So the shaded region is going to be 360. Again, we want to find shaded and unshaded areas. Unshaded. Okay. The area of the rectangle is length times width. So our area is going to be 8 by 13, or 26 times 4, which is 104. We also have triangles. So area of a triangle is 1/2 base times height. So area is going to be 1/2. The base of the triangle is 4. The height is 3. So 1/2 of 4 is 2. 2 times 3 is 6. So we know the area of our triangles is 6. R6 is 6. R6. The area of the triangles is R6. The area of the triangle is R6. Probably. So the total area, so the unshaded area is then going to be 6 plus 6 plus 6 plus 6, which is 24, or we could say 6 times 4. Area of each triangle is 6. There are 4 triangles. 6 times 4 is 24. So unshaded is 24 centimeters squared. Okay, the area of the whole thing, again, the whole thing is 104. We want to subtract the unshaded part, so minus 6, that's minus 12, that's minus 18, and that's minus 24. And we're left with an area of 80. So the shaded region is going to be 80 centimeters squared. Okay. And these are our 2 answers. Okay. All right. (13) and 14. So 13, we have hexagon, regular hexagon. Again, a regular polygon is a polygon that has all the sides are the same length and all the angles are the same measure. So a regular hexagon is one that has 6 sides that are all the same length and 6 angles that are all the same measure. We know the formula for finding the measure of the interior angles is n minus 2 times 180. So in a hexagon, we have 6 sides or 6 angles, so n is going to equal 6. So we can say 6 minus 2 times 180, 4 times 180, which is going to be 720. Okay, so that's the sum of the interior angles. If we want to find the individual interior angles, we have to do 720 divided by 6, because there are 6 angles. So these 6 interior angles add up to 720. Since all of them are the same measure, we can divide by 6, which is going to give us 120. So we know all of these angles are 120. Okay. The sum of the exterior angles is 360. So if we want to find out the individual exterior angles, we would divide by the number of exterior angles, which is 6. So here we go. Here's another one. Here's another one. Here's another one. 1, 2, 3, 4, 5, 6. 360 divided by 6 is going to give us 60. Right? So the sum of the exterior angles, so we have 6 exterior angles, is 360. So if we divide by 6, we can get each individual one, which gives us 60. So A is going to be 60, D is going to be 60, and the rest of these are also going to be 60 degrees. Okay. So we know A is 60, B is 120, C is going to be 120, and D is going to be 60. 14. I'm going to erase this. Again, we also notice these are supplementary, so they add up to 180. Okay. 14, we can break up into 4 different rectangles. This rectangle is 8 by 6, so the area, which is length times width, is going to be 6 times 8, which is 48. This one is also going to be, right, this is 6, so that's 6, is 8 times 6. So again, area is length times width. So 6 times 8, which is 48. This one we notice is 18 by 2. Okay, so 48, 48. This one's length times width again, 2 by 18, which is 36. Okay. That leaves us our 4th one in the middle here, the big one. Right. So if this is 6, we know the opposite side of the rectangle is 6. Since this whole thing is 13, 13 minus 6 is going to give us 7. these two pieces have to add up to 13. So 13 minus 6 gives us 7. So the area is length times width. So we're going to have 7 times, we got to find the width. Well, we know this piece is 18. Opposite side of this rectangle. So this side is 18, this side is also 18. And we know this piece here is 5. So together, 18 plus 5 is going to give us 23. Right? Do we see this? 18 and 5. So 18 plus 5 is 23. Angle addition or segment addition. 18 plus 5 is 23. So we have 7 times 23, which is going to give us 7 times 20 is 140. 7 times 3 is 21. So that's going to give us 161. Okay. So to find the area of the whole thing, so this is 161. So we have one big one. Let me erase this. Right. Okay. So we have 161 plus 48 plus 48 plus 36. So that's 16, 17, 23, 8, 11, 19, 293 centimeters squared is the whole area. Okay, then the last two we have 15 and 16. And 16. Find the following information by a regular 22gon. So a 22gon has 22 sides and 22 angles, so n equals 22. The sum of the interior angles of a 22gon or any polygon is equal to n minus 2 times 180. Okay. So we're going to do 22 minus 2 times 180, which is going to equal 20 times 180, which is going to equal 3,600, right? 180 times 10 is 1,800. Since it's 20, it's going to be 3,600. I hope. Just so we don't screw it up, let's put it in the calculator. $3,600. The formula here is n minus 2. So then it wants to measure each interior angle, n minus 2 times 180 divided by n. Well, we know n minus 2 times 180 is 3,600, and n is 22. So 3,600 divided by 22 is going to give us 1,800 over 11. So 163.6. 163.636. Okay. So just to reiterate, we've talked about this a bunch, but n minus 2 represents the number of triangles you can make. So for example, in the example above here with the hexagon, right, we could make, so here n was 6. We could make 1, 2, 3, 4 triangles. Each triangle has a sum of 180, so we could do 180 times 4 triangles, and that got us a total which was 720. 180 times 4 is 720. So in the 22gon, I think that has to be higher. That was a guess. It was a bad guess. It was a perfect guess. It was a perfect guess. If you know what I'm talking about that. But okay. What was I saying? Yeah, so we can make 20 triangles. Each triangle has 180 degrees. So in a 22 gon, we can make 20 triangles. Each has 180. That gives us our total 3,600. Divide by the number of angles that there are. So there are 22 angles. So we get 163.636. The formula for the sum of exterior angles is 360. So for a 22 gon, it's just going to be 360, just like for every other polygon. The exterior angles are going to add up to 360 because, again, we can make that circle. If we put all those, the endpoints for all those exterior angles, the vertices of all those exterior angles together, we're going to get a circle. So on the hexagon, we got a circle with 6 different angles. And the measure of a circle is 360. That's why this one is always 360. Okay. Part D, we're looking for the measure of each. So that's 360 divided by n. So here we have 360 as the sum of the exterior angles, just like in every other polygon. We have 22 angles or 22 sides. So we divide the total sum of the exterior angles by the 22 exterior angles that we have. And we get, it should be supplementary with 163.63. So without putting in the calculator yet, we know it should be 16.374. Okay, but let's put it in. 360 divided by 22. I don't like how this calculator goes straight to another fraction. Why would I be putting a fraction in, Control, or wait. Nope. Divided by 11. Control Enter. 16. What was I thinking? Okay. Right, and we see that those will be supplementary. Okay, it's 16.3. Here was the one. 16.364. Okay. Number 16. Again, want to find the area, so we can divide it into 3 rectangles and a triangle. So let's start with this rectangle is 8 by 10, so area is length times width. So we have 8 times 10, which is 80. Okay. We know this is going to be 8. So the whole thing here from here to here is 16. We know the length here is 7. So the area of the second one is going to be 7 by 16. Um, 112. 8 times 16 is 128. 128 minus 16 is 112. Right? 16 by 7. Okay. Do we see how we got, so opposite side of the rectangle, so if that's 8, this one is also 8. They're telling us this piece is 8. 8 plus 8 is 16. And then it's telling us 7. So 16 by 7. And the total area for this one was 112. Okay. If this whole thing is, well, let's do this one first. So this is 10. We got to find this piece. So if this is 7, we know that's opposite side is 7. If this is 10, opposite side is 10. We know this whole thing is 21. So 10 plus 7 plus whatever this is should be 21. So we can do 21 minus 7 minus 10. So 7 and 10 is 17. 21 minus 17 gives us 4. So we know this rectangle is 10 by 4. 10 times 4 is 40. So again, this whole thing is 21. We know this piece is 10 because opposite sides of rectangles are the same. We know since this is 7, this piece is 7. Together we have 17. 21 minus 17 is giving us what's left, which has to be 4. So that is 40. The last piece here is the triangle. We know if this is 4, this piece down here has to be 4. We need to find this one. Okay. We know this whole piece is 8 and 8, which is 16. So this whole piece is 16. We know this one is 10. So the whole thing is 16. 16 minus 10 is going to give us 6. So area of a triangle is 1/2 the base times the height. So we have 1/2, 4 times 6. 1/2 times 4 is 2. 2 times 6 is 12. Okay, and again, we know this whole piece has to be 16. The whole thing has to be 16. So this whole thing has to be 16. We know this is 10, so therefore that's 10. So 16, right? This has to be 16. So 16 minus 10 gives us 6. So 4 and 6. 1/2 times 4 and 6 is 12. So to find the whole area, we have to add them together. So 80 plus 112 plus 40 plus 12. So that's going to be 4, 14, 2. So 244. Right? 120, 320, 220 plus 12. So 220 plus 24 is 244. Okay. So that's the review for area. I only had 2 questions like this on there because I thought we covered that pretty well. And you guys were pretty solid on that. So I decided to put more area problems on here. If you're uncomfortable with this, go back to the last 2, the Monday and Tuesday blog posts. There's more videos going over problems like that, especially the Monday one. Again, this is the practice problems and review for the quiz that is going to take place tomorrow on Thursday, January 10th, I believe, right? Today's the 9th, tomorrow's the 10th.